Good morning. Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, August 10, 2021, Tuesday. Yes, and title of talk being as well known to you regarding quality, safety, and engineering in life. Title is Civil Field Engineering Quality AnnexSL COVID-19 SHE, that stands for Safety, Health and Environment. Engineer's role: designs, construction methods, contracts, organizations, communication, coordinations, and why be behind quality of standards. Routine talk, but I don't know how many more talks I have to make about quality. And look at these certificates, which speak a lot. These certificates speak a lot about professionals like me, like thousands and lakhs more all over the world, millions more, and particularly talking about ours, that is Bharat, India, our nation, where I think more than all other places, all other democratic countries places, we have Society of Engineers, largest professional body, and many such more bodies in our country, and also millions engineers coming out from universities every year, then entering into profession, which situation in totality suggests that we must have quality products in manufacturing, in industry, and everywhere. But that situation we should evolve, as such. It speaks different language. That language, at least I cannot understand. Maybe you can understand. I don't know. That language is so much power of professionals must lead to every product being quality one. Because of these likewise certificates expect that our people should honor these certificates, and if these certificates are not honored, this means these are only for purpose of display and that's it, or only for purpose of writing with name these titles. People are degrees in engineering, post degrees in engineering, doctorate in engineering, and of course initially diploma engineering. So many classes of educational grades, and then professional grades like membership, which may be FIE, MIE, AMIE, and many more depending on which institution you come from. These titles are not given just because it is applied for. Enough scrutiny is done on these titles, and then these are granted. These are granted based on certain requirements, certain statutory provision. It may be a registered society or it may be statutory body like Institution of Engineers India, chartered body, which was chartered in 1935 after being established in 1920. Since 1935, it has been working as chartered body, or you can say incorporated by Royal Charter. It must have certain value, and it is by virtue of this educational qualification, professional training, and corporate membership of institution, this body is authorized per statute or per charter. Title of Chartered Engineer, India, Bharat. That means it's not just a document, but a measurement value of certain individual. That individual must understand that quality is a requirement because of this certificate. This certificate is issued based on training and experience along with educational qualification, which means that you have learned a lot post your degree obtaining time. Postgraduate experience is very much important in field of engineering. It may be design or it may be prosecution. Without work experience, one cannot call practical engineer. Practical engineer can be depended upon. Direct educated engineer cannot be depended upon, that's true. One has to learn at least 5 years to 10 years in field of engineering to get into certain level of profile engineer, or you can say a kind of acceptable engineer to society. It's honored. Honor means honor of work, honor of responsibility. If you take responsibility, you commit that one, you deliver work based on quantity and quality, that's honorable, I mean to say, because you contribute to nation building, you contribute to society building, you contribute to development. That's where we stand for. It's now 2021 and we got this charter in 1935. This is not private charter. This is not institution charter. This is charter for people of this country who constitute engineering society. This charter is addressed to every member of institution who was member at time of its incorporation by royal charter and who would be continuous as member of institution, corporate member. And it's not only for this member as I'm talking for all engineers. Engineers have a role to play on quality. This means a role to play in society. It's role of engineers to make sure that society or nation or even other countries who depend on us get quality material delivered. It's no joke, never a joke. I don't consider it a joke. It's a question of responsibility. That quality is job of engineers, of course, it's the job of manufacturers. But manufacturers are also considered engineers. Maybe that manufacturer honor not qualified engineer, but that manufacturer is responsible for industry, for factory, for design, for prosecution, for manufacturing processes, for quality material, for quality process. That is responsibility of manufacturing. That's why it's called product. Product is not just product, natural product. It's product based on natural raw material. After being processed based on design, we get some material called refined material or product. Which product is? Engineering product. It's not ordinary product. It's engineering product. Steel, it may be aluminum, it may be construction of building, it may be concrete, it may be mortar, it may be steel, it may be mechanical activities, it may be lathe machine, it may be electrical equipment, it may be mechanical equipment, it may be whatever you can say, wherever branches of engineering lead to. This institution currently is responsible for 15 branches of engineering. And I'm not saying that this is only 15 branches, there may be more. But what I'm saying is, engineering has no limit. If engineers if engineers have commitment, if engineers believe in responsibility, believe in their engineering role, every product should be quality product. There's no way it can't be. I don't believe that. It has to be quality product. It has to be based on safety standards, quality standards. Engineers must realize quality facts. And if they don't realize, they do not do their job. They do not do their responsibility, I would say. Though it's very harsh statement I am making. But certain facts cannot be denied. Engineers are assets to society, assets to nation, just like doctors and nurses are assets to society, assets to nation. Both are responsible. Engineers are responsible for development, for structural building of society. I mean to say structural development of society, on which society enjoys, society moves. And doctors and nurses are responsible for health care. First, health care responsible because health is a part of safety, health and standards, safety, health and environment. So first requirement is that. That's why I always stress with quality, safety, health and environment. Without safety, health cannot be maintained, and without health, environment cannot be maintained, and without safety, health and environment, our physical existence cannot be maintained. It's just individuality that has to take responsibility of SHE. Individuality means every individual of society, every individual of nation, and every individual of globe. Quality moves with that. Quality of your health is also important. It's not simply you're healthy and you must have a quality of living. Quality of living doesn't mean economical. I'm talking of. No, it's not economical living, it's healthy living. Your mind should be active, your body should be active, it should be healthy, it should be, you mean to say, healthy from each point of view. Overweight, underweight, walking problem, not walking problem. I mean to say, one should be an environment friendly, one should be nature friendly. Nature is very important asset, permanent asset. Nobody can challenge that one. But did you maintain that? That's number one. Why we fail to maintain natural power, natural agencies, natural wealth. Sunlight is natural wealth, rain is natural wealth, storm is natural wealth, earth is natural wealth, water is natural wealth, sky is natural wealth, so solar system is natural wealth. This wealth, these wealthy agencies, these agencies who are responsible for this wealth never send any claim bill to ourselves, to global citizens. We never get any claim bill that pay us this much. Try to make a joke on this. Means I pay for electricity bill, I pay for water bill, I pay for house tax, I pay for every item I claim. I pay means whatever taxes are imposed on me or you, we pay. But nature doesn't cost us. It doesn't demand anything, but it goes on without even demand, delivering to us everything. But we don't value it because it's free. When something is given to you free, for example, your body is free, you don't care for that. That's problem of health. That's problem of safety. That's problem in environment. We caused ourselves, we spoil our safety, we spoil our health, we spoil our environment, and thereby we spoil our own quality system. If every day I feel pain, I feel stressed, I feel strain, my leg is paining, of course, the accident is something else. But in general, I can't walk even for 10 minutes because my body doesn't allow it. I can't stand, I can't write. And there are so many issues which you can take into consideration, and that's called lack of quality in your own health system. You are not healthy. You may be healthy with dress sense. You may be healthy having a car. You are using a car to walk, to move. Means your distance you can't cover by walking. You need some equipment, and that equipment is your transport. So your transport has replaced your health activity. Your health has gone to transport. Your writing has gone to computerized system. These questions must be understood. Your body cannot be robot. Your body is body. It has to be healthy. If you remain healthy, you are lucky. We are getting COVID-19. Why? Because we are not healthy. All over the world, those people who have been fat, who have been abdominous, who have been overweight, who have been diabetic, it was very easy for COVID-19 to touch them, to enter their bodies. Those people who are having health, good health. For example, hire workers, construction workers, factory high level workers who spend their time standing working on machines. Bodily they are strong. You shall find those people who have been healthy. They were not imposed on, they were not impacted upon by COVID 19. Those who are luxurious, those who believe in luxuries, they never come out of car, they never come out of air conditioned offices. Such people who are called middle class or higher middle class, they were impacted certainly for sure. I am not generalizing this statement, it's my observation. Generally, people who use flight, they transmitted this problem, this disease, because they are flight borne. I'm not saying flight is bad, but if you do not think beyond car and flight, if you don't think below that, certainly there's a problem in your mind. Luxury doesn't mean absolute belonging. Luxuries cannot replace my walking. Luxuries cannot replace my food. Luxuries cannot replace my thinking. Yes, I may be having very good house, very good car, but my body cannot be built by house or by car. Only feeling can be done. Okay, I feel I have a house, I feel I have a car, and therefore I feel happy, but happy in mind, not in body. If I am not able to respire pure air, if I am not able to get rainwater pure, if I am not able to get something else which must be my right, because I spoiled that right, I ignored nature. I ignored nature as human being. I did not care for air purity, maintenance. I did not care for nature. I did not take care of trees. I did not take care of grass. And I did not take care of fruits and all wheat grains or whatever products from agriculture, because all these impact good or bad or adverse on our bodies. We spoil everything we could. We can say, I can say, you can say, we are very good kids of God to spoil product produced by God. We can spoil anything God gives us. Millions and millions years it took for reforming fossil fuels and plants which could give us raw petroleum, raw product, slug. And we are so efficient in consuming that it did not take more than 85 years, I think, or let us say 100 years. We could not even cross 100 years since we started extracting oil, exploring petrochemicals from sea or elsewhere, just in a depth of say 2 to 3 to 4 to 5 to 6 kilometers, probably. Hundreds of reservoirs were discovered all over the world, and particularly in the Middle East. These reservoirs of oil could not be kept as wealth, but we explored this wealth and work of God that resulted in millions of years was so quickly extracted out that now nearly can say measured quantity of that fossil fuels and plants based fuel we have consumed. But it's not absolutely consumed, because scientific principle says energy can change form. It cannot be distinct, it cannot be exhausted. So what happened? These fossil fuels, when burnt as vehicle fuel or industry fuel, all its final products, converted products in form of smoke, have gone to air in skies. So we can't call it sky because it's just in range of 20 kilometers from surface of lithosphere. So this envelope which you say aerospace, aero envelope, aero you can say aero volume around lithosphere, air which is a part of earth. Earth means lithosphere plus aerosphere. That aerosphere which we use for our survival of health, survival of respiration, without which we cannot live. We have contributed our lot to pollute that. Pollution, carbon monoxide, carbon dioxide, ethane, propane, butane, whatever, which should be only nitrogen, argon, etc. We have filled it with certain unknown, unrequired, redundant gases, polluting gases to this air. This is our quality system contribution to natural product. And because of air, because of plastic production, ethylene production, we have spoiled our water, our earth, our soil, and by use of chemicals and pesticides, we have spoiled our agricultural system just in greed or in avarice of enhancing production. Output means we are hungry for economical development only without developing nature. We can't even help nature forget development. We are so naughty kids. Though we are very educated, I think all over the world people are very educated, knowledgeable, because there are thousands and thousands scientists and lakhs engineers who are very important assets of world. But we only talk. Talking is our expertise. We only talk. Talking is such a property with everybody which does not allow deep thinking. Talking is good habit. If it is thoughtful talk, it based on contemplation, based on thorough understanding of subject. Talking and length without any width, no meaning exists. If I go on talking and talking just like now I am talking, if I don't think, I don't have any basis, then it's meaningless talk. It is futile talk. You may listen to me for a couple of minutes and then give up. He's just boring us. Yes, when you talk of reality, you talk of facts, you talk of, teasing others, it goes away. Oh, he's boring person. But am I boring? Am I talking something else? I'm talking about quality. Quality everywhere, just like safety everywhere. Quality is not just quality, it's quality of thinking. What do you think? Can you think? You think whole day. If you are a rich man, you think of how to get more money. If you are in education, you think of how to have more education. If you are doing whatever work, you want to reach upper levels. Because hunger never quenches, it's never quenched. Thirst is never quenched. I'm not against your earning more money. I'm not against your upper educational level. But for what? This should be for whole world. If we abuse this money for exploring nature, what nature has given us, and spoil that. Example is plastics, polymers. Example is fossil fuel. Fossil fuels, example is your water, seawater. Millions and millions creatures live in water. Plants, whatever is not available there. We do not know everything till now. It is fortunate that we could not explore Earth so far. except some part of crust, a few kilometers of crust only probably. This crust is upper part of earth, from sea surface or continent surface down to 35 kilometers on an average. You can say this is crust. And we have not been able to explore that till now, and that's thing I think it's in positive sense that God did not allow us, God did not strengthen us to spoil that also. It's not clear what's available beyond crust, what type of metal. We only assume, or we based on electrical transmission, electrical waves, we can say this could be that and that could be this. Means some type of, you can say, hypothetical statements we can make by research. It is geological study, geotechnical study. Even we do not know fully about how, evolution of seismic actions do happen. Well, I don't want to divert from quality and safety, because I say I was inclined to Institution of Engineers India, that it did not do anything like other institutions for purpose of quality issue. I'm not saying that it cannot, but inclination, concentration that every member should have. Institution of Engineers means its members, its corporate members particularly, who are in thousands and maybe lakhs in our country, and those who are not formal members but they are also indirectly ex officio members. All engineers who are well qualified, well experienced, must be considered a society. And this power of engineers, this strength of engineers, is the power of thinking. If you want to quantify power of thinking, you can quantify number of engineers in each branch and multiply by whatever factor. You will find power of that branch, and all such powers from every branch can be summed up to power of nation from engineering behalf, on engineering behalf, from engineering field. That thinking should be immense. I should not say that it's think tank. No, it's think reservoir. It's think reservoir means below sea. We say this is oil reservoir. So I can say we are a thinking ocean, not reservoir alone. Thinking ocean, millions and millions of engineers who are thinkers. If they cannot think, they cannot be engineers. Job of engineer is set aside qualifications. Job of engineer is to think. Think and concentrate on thinking. Because thinking cannot be just thinking. It is based on analysis. It's based on contemplation. It's based on, you can say, requirements. It's part of engineering. Thinking is a kind of template. You have to concentrate on that, and then it becomes concentrated thinking. That can be called contemplation. And if that is achieved, many contemplations are achieved, that can be converted to engineering application. Our application must be affected, and that application can be called engineering. And it has to be conformed with certain designs, certain requirements, certain basics. And if it's not conformed, it cannot be called quality work. And if it's not quality work, it's not engineering work. So simple. Engineering means quality. Engineering means power of specification. Engineering means we know what we have to do before doing that. Not that we have done it and see what's problem. Just like people do start doing something and there's some problem, we'll solve it. Maybe we don't know what problem can be, because we will solve it. We can't anticipate, we can't foresee. This means we cannot understand risk factor. If you want to know risk, possible risk, then you have to do it in advance. And that is only process of thinking that can help you. There's no other way. So thinking is an activity that can be unlimited, and without it there can be no engineer. And forget about engineers also. There can be no one who cannot think. Thinking is God gift. This gift is up to you if you take it or you don't take it. Everybody is a thinker if one realizes. I don't call someone is duffer in this world. Everybody has mind. Now if you have water in your tap and you don't take it out, how can you drink it? Either you take it out, you have to use into your mouth or do something. Same applies to thinking. It's your basics, it's your fundamental, because it's relation to mind. And everybody has mind. Even dogs and horses have mind. Of course, not that level, but they understand. And understanding is mind. It may be wrong understanding, of course, I don't say now, but it can be mind. It is thinking. It can be thinking that goes opposite. It can be thinking that goes positive. Both. I don't know to speech like that, but it's a fact. It is analysis that gives you power, that gives you structural problems. Analysis, professionally considering it, we can say it's a master tool for creating contemplation, for working on contemplation, and for work contemplation. Very, very different approach towards understanding of these factors. Reliability, analysis, synthesis, thinking, applications, contemplation, all these are quality requirements. And then if these are linked to practical of life, and that is cost, that is time, that is risk, these all are covered. I'm not inclined to construction alone. I'm inclined to manufacturing. I'm inclined to production. I'm inclined to everywhere where some product is destined. That product can be design, that product can be physical activity, physical material, that product can be services, results. Product is product, good is good. Product means good or some article of use, article importance of some machine, big machine or small machine, heavy machine or light machine, constructed building or other projects, material in construction, material in manufacturing, parts in manufacturing, manufacturing of parts, construction material, materials production itself. Everywhere if you go in depth, you shall find more and more and more sequences of factual requirement. Those must be valued. Those must be taken care of. It's not just production, we can say. When we do engineering construction, what happens? General trend is that we have to understand what we have to do. We have to plan it. We have a certain budget. We have to work in that budget, within that budget. Then we have to depend on materials. We have to depend on human resources. We have to depend on designs. We have to depend on drawings. We have to depend on all these activities which are not numbered alone. All these activities require some quality. Means every activity should be based on quality. It's not simply final product. If suppose I have to work on cement mortar, I have to select what cement I have to take. I have to decide which one I have to go for, which sand we have to go for, which level of mixing we have to go for, which ratio we have to adopt. Similarly, concrete, which is very widely used material, I think you can say there's no place on earth where concrete is not taken somewhere, it's not installed somewhere. And similarly, concrete has ingredients like cement, supplementary cementing materials, water, sand, aggregate, chemicals, likewise, and certain machine to mix it. We have to take care of each and every material. We have to take care of even water and temporary materials, which require understanding of quality. It's not simply we do like we don't think and do it. Because we have been doing this. We have been doing something, that's okay, but have we been doing to requirement at that point? So quality is very, 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 very different. Engineers must realize quality facts, and in particular civil engineers have to change quality aspect of society, or else quality cannot exist here or somewhere else. It's very much important that we have to understand everything, and that's why I always say quality, safety, health and environment are summed up, and ergonomics is also summed up, and this is required, this summation is required everywhere. You can say this summation is required everywhere in every walks of life. We cannot say simply quality moves alone, or we cannot say safety moves alone, or we cannot say our activities move without these. No activity can be performed without quality point, quality consideration, and no safety can be held without efforts, without keeping eyes open, and without keeping concentration of mind. This requirement exists everywhere in our lives. Every activity we do in our lives, it requires there. And particularly because engineering is overall. If today, wherever we are, we have some relations, our materials have some relations to quality, and quality has relations to all these. In whatever place we sit, we work, we have certain relation. So we may not feel that, but that's a fact. We have relation to quality somewhere. That cannot be denied. Yes, we are ignorant. We forget everything. That's also true. But we have to move like that. We have to work like that. Without this, it cannot move, it cannot go. I always try to explain various aspects of quality. Whatever I think in my mind comes to, I don't prepare anything in advance, because if you are a thinker, you can think a lot. You can think from every aspect. It doesn't matter your thinking goes right or wrong. If it is wrong, it will give you something, or if it's right, it will take something. Means you will give something to work if you think for that positively or affirmatively, and it may be wrong, of course, but that wrong could not be done, may not be done, but it will give some impetus that it can go that way. Safety, quality, work, human resources, material resources, and whatever else are inputs to products. Inputs can be different. Every material has many inputs. Every work has many inputs. Energy, after all, this all is energy. It has to be used properly. It has certain functions to perform. It must. Material cannot be discarded. Every material has certain quality naturally built in that must be understood and utilized. Engineering has gone a long way in understanding all this. I do not say no. Yes, it is a fact. We have already developed too much for applications. It is human weakness that we cannot work like robot, and we cannot work like sun works or other planets work. Because we are human beings, we have very small patience, very small regularity. We can't be nature, but we are part of nature, that we should understand. Our body itself is an example which never stops working. Yes, we take rest, but body doesn't take rest. We feel we are taking rest. In fact, none of our body parts stops. That is lesson we have to learn. God says, never stop. You are working, and that's very important point. It's my body that never stops, and even its solar system that never stops. Its revolution of Earth that never stops. Its orbital movement of planetary bodies around Sun that never stops. This means nature doesn't believe in stopping, but we believe in resting. I can't say stop. Our bodies are not within our controls. Nature is not within our controls. But our thoughts, our contemplation, our thinking, our approach, our hunger for development are very important requirements in this life. We are very weak people, that's why we never continue for work from round clock. We never do that. We only think, okay, I'll do it. But fact remains, I don't do it. I only claim I do it because it's relational talk. It's not absolute talk. I only use something to do. I don't say I do it. If I manufacture concrete, I produce concrete, and I say I have produced this concrete and this work. Yes, what we have done? We have done what I have done? Nothing, in fact. Just some technologies we understood and did that. I don't have basics materials. I don't have materials that I can manufacture. I have to depend on naturally provided materials or ingredients. There is nothing in concrete that I can do myself. I have to depend on aggregates, different kinds of aggregates, different kinds of sands, different kinds of cement, and then water, of course, and then natural impact on that. We must have temperature requirement, we must have air requirement, we must have many factors that all depend on nature. If there is no ingredient of concrete material, how can I say concrete is produced? So in fact, quality means how do you think, what methods you adopt, what sort of technology you use or you develop, means etc. You can say. What machines you use for this, what temporary works or preparatory works you employ for that. All these are collective classification. You have to consider every item in this, everything you have to consider, and only then, after a lot of thinking, you can say this way this concrete can be done. I'm just giving an example. I'm not saying only concrete you have to do. You have to do everything. And quality demands it. Quality is required to be achieved. For this, you have to streamline everyone. You have to streamline commitment, streamline dedication, streamline, you can say, requirement, individual requirement and material requirement, process requirement. There's nothing that we cannot think in, because reliability requires everything, construction requires everything, manufacturing requires everything, and then organization requires everything. Quality must be an input everywhere. It cannot be said that is quality control. Yes, it is quality control, but quality requirement, quality in totality. Therefore, there can be hundreds of definitions of quality while contemplating on this topic. Every material has different technology. Every mechanical material, electrical material, other materials have different technologies. Construction based on all materials. Construction doesn't mean only civil construction. This means construction, public construction, means every construction it is. Very important point, I say, we have to give time to all this, and if we don't give time to all this, I think we do injustice to us, and that injustice factor has to be properly checked in. That is properly checked in. And I said last time that we talked of our hazard control. When I say hazards, this means it's word of safety, it's word of health, where we have to go into depth. We talked about this till now. We have gone through its own statement with definitions and responsibilities, and of course we talked of toolbox talks and start card. We talked of job hazard analysis, which we are doing now, because there are so many hazards categories: chemical exposures, oxygen deficiencies, exposures to ionizing and non-ionizing radiations. We have talked at length in our radiation chapter. Electrical hazards, physical hazards, fire and explosion, temperature controls or extremes, excessive noise, biological hazards. Input should be solicited from multidisciplinary professional staff for hazards evaluation. Then hazard control sheets and various attachments we talked of. We were somewhere now. I'm just refreshing what we did. Then we have various sheets of hazards controls and list of hazards, just for explaining. This is not complete list, limited list it is. And then we have gone through many such talks about various fuels, various machines or equipments, and then electrical activities. Of course, material handling was our point, where we had to now concentrate on material handling. It's very, very significant part of construction, part of engineering, part of, it's not simply construction in every branch of engineering, it can say. Control matches, material handling, manual handling, and it's not just a, and various materials we are going to deal with this because of material handling. And if we start searching on this material handling issue, we may also see what we get, because I simultaneously try to include, I mean to say, material handling, meaning says it's very important part, material handling. It's not handling, handling. Though it's very common, but even then we have to understand it in proper way. It's actually, material handling is movement, protection, storage and control of materials and products throughout manufacturing, warehousing, distribution, consumption, and disposal. As a process, material handling incorporates a wide range of manual, semi-automated, and automated equipment and systems that support logistics and make supply chain work their applications helps with. We can see there are various stages in this: forecasting, resource allocation, production planning, flow and process management, inventory management and control, customer delivery, after sales services. And then you can say, if I take all these points, then it will be difficult to, let us say, I just take a printout of this and show to you, and we'll back everything, see. So I'll just try to take a print of this statement which I'm going to read with you. We'll talk on this, right? Material handling. So what says, this says, that's point here. I will take it later on. Now I have to just, we'll just talk in list, we'll not talk beyond that. And we'll go back to our system. So it says that material handling is movement, protection, storage and control. I think you can see the space, right? You can see the space. Yes, you can see. Material handling is movement, protection, storage and control of materials and products throughout manufacturing, warehousing, distribution, consumption and disposal. It is, again I say, movement, it's movement, protection, storage and control of materials and products throughout manufacturing, warehousing, distribution, consumption and disposal. Being a process, material handling incorporates a wide range of manual, semi-automated and automated equipment and systems that support logistics and make supply chain work. Application helps with forecasting, resource allocation, production planning, flow and process management organization, inventory management organization and control, customer delivery, after sales support and service. A company's material handling system and processes are put in place to improve customer service, reduce inventory, shorten delivery time and lower overall handling costs in manufacturing, distribution and transportation. How is material handling equipment used? There is a variety of manuals. There is a variety of manual, semi-automated and automated material handling equipment and technologies available to aid in movement, protection, storage and control of materials and products throughout manufacturing, distribution, consumption and disposal, which include automated storage and retrieval system, automated storage and retrieval systems, automatic guided vehicle AGV, automatic identification and data collection, casters and wheels, controls, conveyors, dock equipment, ergonomics, hoisting equipment, industrial robots, integrated material handling systems, item order fulfillment systems, lift trucks, monorails and workstations and cranes, overhead cranes, packaging, protective guarding, racks, software, sortation, storage. What is material handling used? Material handling systems are used in every industry, including following but not limited: aerospace, appliance, automotive, beverage, chemicals, construction, consumer goods, e-commerce, food, hardware, hospital, manufacturing, materials processing, paper, pharmaceutical, plastics, retail, warehousing and distribution. What are principles of material handling? When designing a material handling system, it's important to refer to best practices to ensure that all equipment and processes, including manual, semi-automated and automated, in a facility work together as a unified system. By analyzing goals of material handling process and aligning them to guidelines such as 10 principles of material handling, a properly designed system improve customer service. A properly designed system shall improve customer service, reduce inventory, shorten delivery time, and lower overall handling costs in manufacturing, distribution, and transportation. These principles include planning, standardization, work, ergonomics, unit load, space utilization, system, environment, automation, life cycle cost. We'll first see in this principle and then go one by one if I find that website. Planning, you can say, it defines needs. What you plan? Define needs, requirements, strategic performance, objectives, and functional specifications of proposed system, and supporting technologies at outset of design. Plans should be developed in a team approach with input from consultants, suppliers, and end users, as well as from management, organization, engineering, information systems, finance, and operations. All materials are standardization. All material handling methods, equipment, controls, and software should be standardized and able to perform a range of tasks in a variety of operating conditions. Material handling processes should be simplified by reducing, combining, shortening, or eliminating unnecessary movement that shall impede productivity. Examples include using gravity to assist in material movement and employing straight line movement as much as possible. Ergonomics, work and working conditions should be adopted to support abilities of worker. Work and working conditions should be adapted to support abilities of a worker, reduce repetitive and strenuous manual labor, and emphasize safety. Unit load, because less effort and work is required to move several individual items together as a single load. Less effort and work is required to move several individual items together as a single load as opposed to moving many items one at a time. Unit loads such as pallets, containers, or totes of items should be used, says unit load, because less effort and work is required to move several individual items together as a single load as opposed to moving many items one at a time. Unit loads such as pallets, containers, or totes of items should be used, which we do. Space utilization, to maximize efficient use of space within a facility. It's important to keep work areas organized and free of clutter. Free of clutter, CLUTTER, to maximize density in storage areas without compromising accessibility and flexibility, and to utilize overhead space. In 7. System. Material movement and storage should be coordinated throughout all processes, from receiving, inspection, storage, production, assembly, packing, packing, unitizing, and order selection, to shipping, transportation, and handling of returns. Environment, energy use, and potential environment impact should be considered when designing system, with reusability and recycling processes implemented when possible, as well as safe practices established for handling hazardous materials. Automation to improve operational efficiency, responsiveness, consistency, and predictability. Automated material handling technologies should be deployed when possible and where they make sense to do so. Life cycle cost. For all equipment specified for system, an analysis of life cycle cost should be conducted. Areas of consideration should include capital investment, installation, setup, programming, training, system, testing, operation, maintenance and repair, reuse value, and ultimate disposal. I can say we should concentrate on this before going further. If I can find that, it shall be really good. I leave you for time being. I think maybe 2-3 minutes early it is. It doesn't matter. Let me see how can I do it. Material handling I was talking of last time, and this is really something interesting in material handling. I say material handling. So material handling is saying I think we are doing that. So we say, for example, how is material handling produced? Automated storage and retrieval system. This is, for example, we'll go one by one in this michi.org. I'll come out and take it back. Let me go now for my issue that I discussed with you. Principles you can read by the time. I'll be back. Okay. Alright, let us see what happens now. Go to see how it works. Okay, it's fine. Now, I think you have done by this time. You have gone through what I said, what are principles of matter handling you have gone through. Now, we like to see how it works otherwise. In hazards control, we are talking about material handling, and that's very important. First, we have to learn what is material handling, because control list is very small. Let's say how it works. Now, I'll go to stop to open another one. Open this same material handling file again, because I left it closed. So material handling, I'll say material handling here, and this comes in as this site WWMHI hall. I'll go to this one and see how it works. So I have taken this list here. I'll go to that one again. Material handling equipment use, let's say material handling equipment use, which I already discussed. The one by one we'll do that. Let's say this one, and I print out this. What is automatic stages to travel, and then we can say automated stages to travel, then we can say benefits, then we can say automated storage and beverage, and then we can say about automated storage, and done. So we can say this. To be very frankly speaking, I'll go back a little. It's not that exactly. So what we say here, I think lost something. I should not be in that hurry. Automatic storage. I'll take this title page. Just hold on, please. I'm coming back. So we'll take print of this and see how it works. It's very, very important, and we take print of this so that I work well. I put offside then, because on all 3 pages only, no problem. We'll take this matter here. Automated storage and retrieval system. This is overview. Now, automated storage and retrieval systems, sometimes known as ASRS, that is automated storage and retrieval system, sometimes known as ASRS or ASRS, are made of a variation of computer control systems that automatically place and retrieve loads from set storage locations in a facility with precision, accuracy, and speed. And what is this automated storage and retrieval? What is this in fact? That is automated retrieval. Let's see what is this. An automated storage and retrieval system is a combination of equipment and controls that handle, store, and retrieval materials as required with precision, accuracy, and speed under a defined degree of automation. Systems vary from similar automated systems to larger computer controlled storage retrieval systems totally integrated into a manufacturing and or distribution process. Generically speaking, automatic system retrieval systems refer to a variety of computer controlled automatic storage retrieval system refers to a variety of computer control methods for automatically depositing and retrieving load to and from defined storage locations. Within this automatic storage retrieval system environment, one would find one or more of following technologies: unit load ASRS, mini load ASRS, vertical lift modules VLM, shuttles, horizontal carousels, vertical carousels, cube-based storage. So let's go one by one. This unit load, this is ASRS, machines that store large loads, usually more than 1,000 pounds, typically on pallets with storage that structure reach 100 feet or more tall. Mini load, operating same as unit load. This is mini load now. A mini load handle lighter loads, usually less than above. Vertical lift modules VLM Vertical lift modules consists of a column of trays and front and back of module with an automatic inserter extractor in center that stores and retrieves required trays. VLM. Vertical lift module. Shuttles are used for automated handling of totes, trays, cartons, or all three in same system for either warehousing or manufacturing. Horizontal carousels, ideal for storing small parts and pieces. Horizontal carousels are comprised of a series of bins that rotate horizontally around a track. Vertical carousels rotating vertically like a Ferris wheel. Vertical carousels house a series of shelves or carriers to provide high density storage. Horizontal carousels for storing small parts and pieces. Horizontal carousels are comprised of a series of bins that rotate horizontally around a track, and vertical carousels like a Ferris wheel. Vertical carousels house a series of shelves or carriers to provide high density storage. Cube-based storage. Ultra-high density goods to person piece picking system which utilizes robots to store and retrieve entry bins from a cubicle storage grid. Automated storage retrieval systems are used in a variety of areas to support processing and picking throughout a facility. Order picking, storage, kitting, consolidation, assembly, production, replenishment, security, retail. Let's go one by one. Order picking, retrieving, and presenting required inventory to pickers. Storage providing dense long term buffering for small or large items that are slow to medium movers. Knitting, kitting, providing an area to group component parts for assembly. Consolidation, providing a dynamic area to hold parts and items until all pieces of an order can be merged. Ready for shipment, often used for consumer B2B and store orders. Assembly, storing work piece components for later production. Production, storing tooling and components parts for manufacturing processes. Replenishment, storing excess inventory for stocking of ancillary picking systems. Security, providing an enclosed storage environment with software access controls. Retail, providing a large quantity of parts and items at a customer service desk keeps workers in front of customers instead of walking and searching in back room. Automated storage and retrieval systems provides a variety of benefits. Increases throughput capabilities, increases accuracy levels to 99.99% plus, increases ergonomics by delivering items to operators at a convenient height, eliminating time lost to walking, searching, lifting, bending, and twisting activities. Provides highest possible storage density, saves up to 85% of otherwise wasted floor space, increases labor productivity up to 85%, enhances product security, provides real-time inventory control. Automatic storage and retrieval systems are used in variety of industries including automotive, beverage, electronics, e-commerce, food, hajmat, hospital, jewelry, life sciences, manufacturing, medical devices and equipment, maintenance and repair operations, MRO, that is maintenance and repair operations, paper, pharmaceutical, plastics, spare parts handling, warehousing and distribution. Then you can see, we have to go to another one. Let me save this one better because it's for our use. We can use it. Automated storage driver systems. automated storage and retrieval system. Maybe I have other one, this one. Automated retrieval system. Material handling I should take better. Material handling I should say. Material handling I can write here. Material handling, so it should be in the same line. So this is material handling I have taken here. So I can now put this off and go to other one. Principles we have already taken, so I think I go back to this one and let's see. It says we have gone through this list. Now we take another list and that is here. Learn more about automated storage retrieval system. Automated storage retrieval system, industry group, members standards, auto fulfillment. So let's take this one. We'll take this one and let's see how it happens. Automated storage retrieval system are members. I don't think it's something reasonable. Oh no, it's not very attractive. I leave it. It's not that automated storage retrieval system. This is retrieval system overview. I don't know where it's gone. That's going to be useless. I don't know. Sometimes I take time and waste your time. Sorry for that, because it's not giving me required input. Now here is it is here. Let me take something out here. Community. Solutions, community members are industries, thought leaders in automation. Leave it. It's no use, and I'm not going to waste time on this unnecessarily. Okay, we go back now. It's no use. I'll go to some other search, maybe possibly. This is material handling, Wikipedia. Let's see this one, what it says. Maybe it's better than something else. Yeah, I think it's better than something else, of course. This is print. I'll show you this material and Wikipedia. It's better than something else, I think. Yes. Yes, each 6 pages, fine, it's okay. Material handling, says material handling. Material handling involves, let's see what's browsing in this gives me role. Let us read this. It's easy, So material handling involves short distance. Let me close other material handling. The unnecessary keeping is no meaning. And material handling was that one. This also is gone. I'll keep this off. Alright. Material handling, let me save this file as well better. Material handling I can write. Alright. Okay, it's material handling, fine. Material handling involves a short distance movement within confines of a building or between a building and transportation vehicle. It uses a wide range of manual, semi-automated and automated equipment and includes consideration of protection, storage and control of materials throughout their manufacturing, warehousing, distribution, consumption, and disposal. Material handling can be used to create time and place utility through handling, storage, and control of waste, as distinct from manufacturing, which creates form utility by changing shape, form, and making up material. Design of material handling system, unit load concept, in process handling, distribution, health and safety, type, manual handling, automated handling. See also. Okay, now role. Let's say role. Material handling. Let me just make 145. Material handling plays an important role in manufacturing and logistics. Almost every item of physical commerce has been transported on a conveyor or lift. Almost every item of physical commerce has been transported on a conveyor or lift truck or another type of material handling equipment in manufacturing plants, warehouses, and retail stores. While material handling is usually required as part of every production worker's job, over 650,000 people in the United States work as dedicated material movers, machine operators. So this is only US. We can say millions all over the world, crores, and have a median annual wage of whatever. These operators use material handling equipment to transport various goods in a variety of industrial settings, including moving construction materials around building sites or moving. So we can say this 650,000 is very, very small. It can be maybe say 50 crores around world. You may say 10%, let us say 15 crores in our country, Bharat, maybe. At least we say 10% of total people, or 5%, maybe less. I don't have statistical data, but it should be many, many crores. That's indeed true. Designs of material handling systems. This is a chart here, material flow diagram between activities and layout. So here, as you can say, yard of metal comes from everywhere. It goes in, then goes out like that. Or it says material handling is It's integral to design of most production systems. Since efficient flow of material between activities of production system is heavily dependent on arrangement or layout of activities. If two activities are adjacent to each other, material might easily be handled from one activity to another. If activities are in sequence, a conveyor can move material at low cost. If activities are separated, more expensive industrial trucks or overhead conveyors are required for transport. High cost of using an industrial truck for material transport is due to both workers' cost of operator and negative impact on performance of production system, namely increased work in process when multiple units of materials are combined into single transfer batch in order to reduce number of trips required for transport. So you can see this chart here, and here is many points are given, many rectangles are given, and this is sale area here, and this is you can see, I know what's written here not clear, well, whatever it is, but material flow diagram between the activities and layout. And now unit load concept. It says a unit load is either a single unit of an item, or multiple units, so that arranged or restricted that they can be handled as single unit and maintain their integrity. Although granular, liquid, and gaseous materials can be transported in bulk, they can also be contained into unit loads using bags, drums, and cylinders. Advantages of unit loads are that more items can be handled at same time. thereby reducing number of trips required and potentially reducing handling cost, loading and unloading times and product damage, and that it enables use of standardized material handling. Equipment disadvantages of unit loads include negative impact of batching on production system performance and cost of returning empty containers, pallets to their point of origin. Here, production batch can be split into a smaller transfer batch containing several units, each of which can contain multiple parts. Here it is production batch. You can see transfer batch. This is transfer batch, and you can say here this is production from here. Unit load, it's unit load, and this is single part. So this is just for application. Now, in process handling, unit loads can be used both for in-process handling and for distribution, receiving, storing, and shipping. Distribution is receive it, store it, and ship it. Unit load design involves determining type, size, weight, and configuration of load, equipment and method used to handle load, and methods of forming or building and breaking down load. For in-process handling, unit load should not be larger than production batch size of parts in process. Large production batches used to increase utilization of bottleneck activities can be split into smaller transfer batches for handling purpose, where each transfer batch contains one or more unit loads, and small unit loads can be combined into larger transfer batch to allow more efficient space transport. Stretch wrapping machine used to form a unit load. Distribution. Selecting a unit load for distribution can be difficult because containers, pallets are usually available only in standard sizes and configurations. Truck trailers, rail box cars, and airplane cargo bays are limited in width, length, and height. A number of feasible containers, pallet sizes for a load may be limited due to existing warehouse layout and storage rack configurations and customer package, carton size, and retail store shelf restrictions. Also, practical size of a unit load may be limited by equipment and AnnexSL space available and need for safe material handling. Narrow AnnexSL lift truck used in distribution. Health and safety. Manual material handling work contributes to large percentage of over 500,000 cases. A musculoskeletal disorder, we discussed before this. Manual material handling work contributes to a large percentage of over 500,000 cases of musculoskeletal disorders. MSD reported annually in US. MSD disorders, musculoskeletal disorders, often involve strains and sprains to lower back, strains and sprains to lower back, shoulders, and upper limbs. They can result in protracted pain, disability, medical treatment, and financial stress for those afflicted with them. And employers often find themselves paying bills either directly or through workers' compensation insurance. At same time, they must cope with loss of full capacity of their workers. Scientific evidence shows that effective ergonomic interventions can lower physical demands of MMH work tasks, thereby lowering incidence and severity of musculoskeletal injuries they can cause. Potential for reducing injury-related cost alone make ergonomic interventions a useful tool for improving a company's productivity, product quality, and overall business competitiveness. But very often, productivity gets an additional and solid shot in arm when managers and workers take a fresh look at how best to use energy, equipment, and exertion to get job done in most efficient, effective, and effortless way possible. Planning that Planning that applies these principles can result in big wins for all concerned or types. Manual handling. Manual handling refers to use of a worker's hands to move individual containers by lifting, lowering, filling, emptying, or carrying them. It can expose workers to physical dangers that can lead to injuries. A large percentage of over 500,000 cases of musculoskeletal disorders reported in United States each year, and you can say crores cases around world each year arise from manual handling and often involve strains and sprains to a person's lower back, shoulders, and upper limbs. Ergonomic improvements can be used to modify manual handling tasks to reduce injury. These improvements can include reconfiguring tasks and using positioning equipment like lift, tilt, turntables, hoists, balancers, and manipulators to reduce reaching and bending. NIOSH, National Institute for Occupational Safety and Health, National Institute of Occupational Safety and Health, 1991, revised lifting equation can be used to evaluate manual lifting tasks. Under ideal circumstances, maximum recommended weight for manual lifting to avoid back injuries is 51 pounds, 23.13 kg, using exact conditions of lift, height, distance, lifted weight, position of weight relative to body, asymmetrical lifts and objects that are difficult to grasp, using exact conditions of lift, height, distance, lifted weight, position of weight relative to body, asymmetrical lifts and objects that are of difficult to grasp. 6 multipliers are used to reduce maximum recommended weight for less than ideal lifting tasks. Automated lifting, handling. Automated handling. Whenever technically and economically feasible, equipment can be used to reduce and sometimes replace need to manually handle material. Most existing material handling equipment is only semi-automated because a human operator is needed for tasks like loading, unloading, and driving that are difficult and or too costly to fully automate. However, ongoing advances in sensing, machine intelligence, and robotics have made it possible to fully automate an increasing number of handling tasks. A rough guide to determine how much can be spent for automated equipment that would replace one material handler is to consider that with benefits, median moving machine operator costs a company how many dollars can see per year. Assuming a real interest rate of 1.7% and a service life of 5 years for equipment with no salvage value, a company should be willing to pay to this much. Forget that task, okay? To purchase automated equipment to replace one worker. In many cases, automated equipment is not as flexible as a human operator, both with respect to not being able to do a particular task as well as a human and not being able to be as easily redeployed to do other tasks as needed changes. In this case, there are so many others, that is automated storage and retrieval system, automation, bulk material handling, college industry council on material handling education, conveyor system, human factors and ergonomics, industrial robot, material handling equipment, warehouses, unit loads. So there are certain notes now. I think we have done this paper. So we'll go back. I think I've saved this. Better I say, I think I saved it, right? It was saved, I am sure. Let me do it again, no problem. If it is, so fine. Okay, it's access. So now we'll go to hazards control, and I'll be back within 2-3 minutes because of I will take some water. And let me also close this because enough is done on this. I'll take a closer on that. That's it. You can see that. this is material handling actually doing. Now we have to see hazards controls we are talking of. Control measures, we're talking of manual handling back injuries. Says whenever practicable, mechanical lifting aids, namely cranes, forklifts, trucks, etc., shall be used to alleviate requirements for manual handling. We have gone through this and seen that already. Supervision shall assess weight, center of gravity, etc., and determine number of persons required to carry out work safely. This is technical requirement. Center of gravity, weight, means we have to think physics. What is weight of that material? Where is center of gravity? And how many persons are required to carry out this work safely for material handling? Personnel should be trained in safe manual handling technique, which are many times too useful to save time and cost. Means how to best handle material in what way. That should be first devised and then explained to them. This is not only saving time and cost but also physical exertion to workers. Gloves, safety footwear and goggles to be worn by personnel engaged in material handling. That is very common, that we have to force them as a rule for implementation to use personal protective equipment. Good housekeeping measures are required and shall be enforced in order to prevent slips, trips and falls. That is, good housekeeping measures are required, shall be enforced. Housekeeping is basic requirement everywhere. Means there should be no slip, there should be no trips and there should be no falls during material handling. Materials shall be stored in designated areas. Storing should be conducted systematically. Materials shall be stored in designated areas and storing should be conducted systematically. Material that is required for finishing items should be separately stored to avoid damage by hard materials. Material shall be stored in designated areas. Storing should be conducted systematically. And material that is required for finishing items should be separately stored to avoid damage by hard materials. Material should be stored in such a manner that issues to site from stocks or stores should be conducted in professional manner. Without damages either to workers or to personnel. Material should be stored in such a manner that issues to site from stocks or stores should be conducted in a professional manner without damages either to workers or to personnel. During manual handling, single pieces safety officer or foreman should instruct personnel to handle in such a way that least impact is transferred to worker's body. Cement bags should not be transported by putting on heads or personnel. Steel bars should not be carried by keeping on shoulders of workers en route to site locations from fabrication yard. Handling of steel. Again, the hazards can be trapping injuries, falling material, manual handling, slips, trips and falls. Handling of steel, control measures. Personnel to wear suitable gloves, footwear and goggles when handling steel rebars. Personnel to be trained in slinging and banksman technique in order to ensure materials are lifted in safe manner. Suitable equipment is to be used to lift steel work. Steel shall be stored in designated area on wooden skids or sleepers. Good housekeeping standards shall be maintained in steel laydown areas in order to prevent slip, trips and falls. Tug lines shall be used when lifting traveling materials by cranes. Personnel not involved in any steel handling operation to be kept clear of from area of work. If I can find something, I'll be here to see, and maybe those very basics, but if I can found, let's say, steel reverse handling. Okay, I have something. I'll take print out and show to you that one. It's taking some time. Maybe image is very dense here, but no problem. Let us see how it works. Meanwhile, still loading preview. I don't want. Yeah, it's not coming yet. Hold on, please. Let it come. It's still loading preview. It takes time. It's maybe reinforcing bars. It's going to show. Right. So I don't know, but maybe I disconnect my. I don't know. Can disconnect my video. Probably it's not giving answer. Although it was good one. Let me then go back. It's taking a lot of time, so I'll go to somewhere else. Handling of storage reinforcing bar CRSI. What is the CRSI? Central Research. Okay, let's say it's text only, so let's take it right. Okay, print. There's no print, so it's printed out. Okay, fine. I'll take care of this, and we'll talk of this CRSI concrete. It says reinforcing bars. Talking of reinforcing bars, I think I'm getting image. You're getting this here. I am sure you must be getting it here. Yes, you are getting it here. It's okay. So this metal handling, I put it off because this is this is still done. It's done. Okay, we have done it. So we can remove this. I think we can remove this. So I can remove this from here. To handling and storage. Now it is reinforcing bars. Reinforcing bars are shipped from factory for specific parts of structure. Reinforcing bars are shipped from fabricators for specific parts of structure. When conditions at job site permit, reinforcing bars are delivered to storage or laydown area, and unloading shall be as directed by iron worker foreman, steel worker foreman. All deliveries be made easier by suitable ground and roadway conditions. A shipping list of manifest, sometimes called a dray ticket or load sheet, accompany each shipment and list material contained in shipment. When power hoisting equipment is not available, bundles of reinforcing bars may be skidded from truck over timbers or rails, extending from truck bed to ground. Timbers dunnage should also be located on ground to support and elevate bundles and keep them free from mud on job site. Bars are most economically moved from truck to an area close to where they are to be used. When reinforcing bars are unloaded to storage area, it is important that location of area be selected for easy access by truck and rehandling of bars to area of placement in structure. When a bundle is opened and some of reinforcing bars are removed, bars with tag should remain with bundle. Simple steps save time and effort. Order reinforcing bars with construction schedule in mind. That's number one. Do not order without construction schedule. When the reinforcing bar is delivered to site, when reinforcing bar is delivered to site, order, as I said before, again I say, order reinforcing bar with construction schedule in mind. When reinforcing bar is delivered to site, check shipping list or manifest dry ticket or loading sheet as each bundle is unloaded. Save time by hoisting bundles of bars directly from truck to area on structure where bars are going to be replaced. Put bundles in an area with easy access for a handling. Make sure reinforced bars placed on timbers to keep it away from mud or standing water. Keep stockpiles orderly. Straight bars are usually stored by sizes and by lengths for easy identification. Stockpile similar bent bars together. Make sure all bar tags are same and for quick identification. When bars are removed, make sure bar tag stays with bundle and doesn't get lost. Field bending, straightening and rebending reinforcing bars. Normal realignment of number 7 through number 18 bars up to about 30 degrees bend, or number 3 through 6 bars up to about 45 bend should not require an engineer's approval. Iron worker, steel worker must take care to guard against injury or falling if reinforcing bar breaks while it is being bent. Iron or steel worker must take care to guard against iron injury or falling if reinforcing bar breaks while it is being bent. It may be necessary to heat bar to prevent breakage. It may be necessary to heat bar to prevent breakage, but heating should be done only with approval of engineer. Otherwise, don't do it. Field bending, straightening, or rebending of dowels should not be done. Field bending, straightening, or rebending of dowels should not be done in extremely cold weather conditions unless dowels are preheated first as approved by engineer. Well, cutting reinforcing bar at a project site. Occasionally, field cutting is required when reinforcing bars are too long as a result of design changes or errors made in detailing, fabrication, or placing. Field cutting is sometimes needed with over-length bars prior to placement in formwork or where partially bars are embedded in hardened concrete. For uncoated reinforcing bars, use bolt cutters or smaller size bars. For bar sizes number 19, larger use an oxyacetylene torch to flame cut. For uncoated reinforcing bars, use bolt cutter on smaller size bars 10, 13 and 16 number. For bar sizes number 19 and larger, use an oxyacetylene torch to flame cut. Smaller size epoxy coated bars 10, 13, 16 can also be cut with bolt cutter. However, do not use a flame torch to cut larger epoxy coated bars. Instead, use a saw with a diamond blade. After cutting epoxy coated reinforcing bars, cut ends are to be coated with 2 parts epoxy patching material. So this is CSI handling, material handling steel. We can save it as here. Just see procedure, CSRI steel, material handling steel. Handling rebars. So we'll close it down and let's see if I can something else there. If I can find something else, let's see. Handling, so bars. I'll see. Let me see if I can get something out of this, if it allows me. It's allowing me. Okay. Batons. Way of handling and storing reinforcing bars. Let's excuse first what it says. So only small it is. We can take batons. Let's say way of handling and storing reinforcing bars. How to handle and store black bars, black rebars. Avoid treating rebar roughly. Lesson number 1. Let me save file first, otherwise I forget. Metal handling. Avoid treating rebar roughly. Use normal handling tools and machines such as slings, bear chains. Storage should be covered with polythene or polyethylene sheeting or other appropriate material if rebars are kept out of doors. Very important point here. Avoid treating rebar roughly. Use normal handling tools and machines such as slings, bear chains should be covered with polyethylene sheeting or other appropriate material if rebars are kept out of doors. Methods and how to handle store epoxy coated rebars off ground first of all. Then use spreader bars. Handling is use spreader bars or strong backs with multiple pickup points to minimize sags. Use synthetic slings to reduce damage to coating. First is use spreader bars or strong backs with multiple pickup points to minimize sag. Use synthetic sling to reduce damage to coating. Avoid using bear chains and cables. Avoid dragging and collision. All contact points should be wood or plastic when shipping. Should be wood or plastic contact points. Protect coating by using foam between bar and strapping. Off-ground storage on suitable materials such as timber, cribbing, wooden boards. Should be placed free from mud, debris and other deleterious material. How to soak galvanized rebars. Galvanized rebars, batons. Avoid treating rebar roughly. Use normal handling tools and machines such as slings, bear chains. Storage. Avoid contacting with or uncoated rebars. Avoid long time placing on wooden materials which easily lead to surface staining. Off ground. How to handle and store stainless steel bars. Using plastic stainless steel wire. Using plastic stainless steel wire or synthetic straps when strapping. Use synthetic straps when lifting. Avoid using carbon steel lifting device. Avoid using bear chains and steel bands. If it is inevitable, using something to isolate them from rebars to prevent direct contact with ferrous materials. Storage. Off ground on suitable materials. Avoid contacting with or beneath carbon steel, rebar or other ferrous materials. Should be put on top if contacting with ferrous material is inevitable when shipping. Should be covered with polyethylene sheeting or other appropriate material if rebars are kept out of door. this was direction on these batons, and there are so many other points can be linked to this, but I'm not going to take that one because I have saved that, and that's okay for you people. And it is handling okay. We have done it, finish. And now we'll go back. Now we come on to, we'll also say if something is available there. Can see, let's go back here and see how to store steel on site. Okay, it's concrete outer steel on site. So toptech.com, leave it. Wikipedia, yes, past Wikipedia. Let's see, Wikipedia also once. It's also very powerful tool. It's better, I think. We can, let us see if I can do it. Print it and I'm taking time, but it's useful for everybody. I'm saying, yeah, it's come. Metal handling. Rebar handling. What's that? Rebar. Okay, that's rebar. It's metal handling actually. Alright, now it's rebar, it's Wikipedia. Short for reinforcing bars and rebar cells, okay. Known when masked as reinforcing steel or reinforcing steel, with a steel bar or mesh of steel wires used as tension device in reinforced concrete and reinforced masonry structures to strengthen and aid concrete under tension. Concrete is strong under compression but has weak tensile strength. Rebar significantly increases tensile strength of structure. Rebar surface is often deformed with ribs, lugs, or indentations to promote better bond with concrete and reduce risk of slippage. Most common type of rebar is carbon steel, typically consisting of hot rolled round bars with deformation patterns. Other readily available types include stainless steel and composite bars made of glass fiber, carbon fiber, or basalt fiber. Steel reinforcing bars may also be coated in an epoxy resin designed to resist effects of corrosion, mostly in saltwater environment, but also land-based constructions. Bamboo has been shown to be variable alternative to reinforcing steel and concrete construction. These alternate types tend to be more expensive or may have lesser mechanical properties and are thus more often used in specialty construction where their physical characteristics fulfill a specified performance requirement that carbon steel does not provide. Steel and concrete have similar coefficients of thermal expansion, so a concrete structure member reinforced with steel experience minimal differential stress as temperature range. History. Okay, let us see, no problem. Reinforcing bars in masonry construction have been used since least 15th century. 2,500 meters of rebars were used in Chateau de Visnets. Okay, this is history. I think I should not waste time in this. My purpose is not history. So, used in concrete and masonry. Concrete is a material that is very strong in compression but relatively weak in tension. To compensate for this imbalance in concrete behavior, rebar is cast into it to carry tensile loads. Most steel reinforcement is divided into primary and secondary reinforcement, but there are other minor uses. Primary reinforcement refers to steel which is employed to guarantee resistance needed by structure as a whole to support design loads. Secondary reinforcement, also known as distribution or thermal reinforcement, is employed for durability and aesthetic reasons by providing enough localized resistance to limit cracking and resist stresses caused by effects such as temperature changes and shrinkage. Rebar Rebar is also employed to confer resistance to concentrated loads by, by providing enough localized resistance and stiffness for a load to spread through a wider area. Rebar may also be used other to hold other steel bars in correct position to accommodate their loads. External steel tie bars can constrain and reinforce masonry structures as illustrated. Masonry structures and mortar holding them together have similar properties to concrete and also have a limited liability to carry tensile loads. Physical characteristic: steel has a thermal expansion coefficient nearly equal to that of modern concrete. If this were not so, it would cause problems through additional longitudinal and perpendicular stresses at temperature different from temperature of setting. Although rebar has ribs that bind it mechanically to concrete, it can still be pulled out of concrete under high stresses, an occurrence that often accompanies a large-scale collapse of structure. To prevent such a failure, rebar is either deeply embedded into adjacent structural members, 40 to 60 times diameter, or bend in hooked at ends to lock it around concrete and other rebars. This first approach increases friction locking bar into place, while second makes use of high compressive strength of concrete. Common rebars. Common rebar is made of unfinished tempered steel, making it susceptible to rusting. Normally, concrete cover is able to provide pH value higher than 12, avoiding corrosion reaction. Too little concrete cover can compromise this guard through carbonation from surface and salt penetration. Too much concrete cover can cause bigger crack widths, which also compromises local guard. As rust takes effect, as rust takes up greater volume than steel from which it was formed, it causes severe internal pressure on surrounding concrete, leading to cracking, spalling, and ultimately structural failure. This phenomenon is known as oxide jacking. Oxide jacking. This is a particular problem where concrete is exposed to salt water, as in bridges where salt is applied to roadways in winter, or in marine applications. Uncoated, corrosion resistant, low carbon, chromium, microcomposite, silicon, bronze, epoxy coated galvanized or stainless steel rebars may be employed in these situations at greater initial expense, but significantly lower expense over service life of project. Extra care is taken during transport, fabrication, handling, installation, and concrete placement process when working with epoxy coated rebars. Because damage or reduced long-term corrosion resistance of these rebars, even damaged epoxy coated bars have shown better performance than uncoated reinforcing bars, though issues from debonding of epoxy coating from bars and corrosion under epoxy film have been reported. These epoxy coated bars are used in over 70,000 bridges decks in USA, but this technology was slowly being phased out in favor of stainless steel rebars as of 2005 because of its poor performance. Requirements for deformations are found in USA standard product specifications for steel bar reinforcing, such as ASTM 6, A615, ASTM A706, and dictate lug spacing and height. Fiber reinforced plastic rebar is also used in high corrosion environment. It's available in many forms such as spirals for reinforcing columns, common rods and meshes. Most common commercially available rebar is made from unidirectional fibers set in thermoset polymer resin and is often referred to as FRP, fiber reinforced plastic polymer. Some special constructions such as research and manufacturing facilities with very sensitive electronics may require use of reinforcement that is non-conductive to electricity, and medical imaging equipment rooms may require non-magnetic properties to avoid interference. FRP rebar, notably glass fiber types, have low electrical conductivity and are non-magnetic, which is commonly used for such needs. Stainless steel rebar with low magnetic permeability is available and sometimes used to avoid magnetic interference issues. Reinforcing steel can also be displaced by impacts such as earthquake, resulting in structural failure. Prime example of this is collapse of Cypress steel state in Auckland, California, as a result of 1989 Loma Prieti earthquake causing 42 facilities. Shaking of earthquake caused rebars to burst from concrete and buckle. Updated building designs, including more circumferential rebars, can address this type of failure. Sizes and grades. US size. US or imperial bar sizes give diameter a unit in units of 1/8 inch. Unit of 1/8 inch is 3.2 mm. For bar size number 2 through number 8, so that number 8 is equal to 8/8. Oh, I see. Bar size 8. So that number 8 is equal to 8/8 inch equal to 1 inch. 25 mm diameter. The cross-sectional area given by pi square works out to bar size, whatever it is, which is approximately bar size over 9 square inches. For example, area of 8 number bar is 8/9 whole square, 0.79 square inches. Bar size larger than number 8 follow 1/8 inch rule imperfectly and skip sizes numbers 12, 13 number, for example, and 15, 17 due to historical conventions. In early concrete construction, bars 1 inch and large were only available in square sections, and their large format deformed round bars became available around 1957. Industrial manufactured them to provide cross-sectional area equivalent of standard square bar size that were formerly used. Now, is that diameter of equivalent large format round shape is rounded to nearest 1/8 inch to provide bar size. For example, number 9 bar has a cross section of 1 square inch and therefore a diameter of 1.128 inches. 10, 11, 14, 18 size correspond to 1/8 inch, 1/8 inch, 11, 1/4 inch, and then 14 is 1.5 inch, and 18 is 2 inches square bars. So sizes smaller than number 3 are no longer recognized as standard sizes. These are most commonly manufactured as plain round undeformed rod steel, but can be made with deformations. Size smaller than number 3 are typically referred to as wire products and not bar, and specified by either their nominal diameter or wire gauge number. Number 2 bar are often informally called pencil rod, as they are about same size as pencil. when US imperial size bars are used in projects with metric units, equivalent metric size is typically specified as nominal diameter rounded to nearest millimeter. These are not considered standard metric sizes and thus is often referred to as soft conversion or soft metric size. US imperial bar size system recognizes use of true metric bar size number 10, 12, 16, 20, 25, 28, 30, 40, 50 and 60 specifically, which indicates nominal bar diameter in millimeters as an alternate size specification, substituting a true metric size for US imperial size called hard conversion, and sometimes results in use of a physically different size bar. There are no fractional bar sizes in this system. Number symbol in this system indicates number sign, and thus number 6 is read as number 6. Use of number sign is customary for US sizes. However, no number is sometimes used instead. There is size here. You can see imperial and metric. Imperial bar size 2, soft size is number 6. 3 mm each, 1/8 is 3 mm, 3 is 24, so 2 to 3 6. 3 is 10, number 2 is 6, number 3 is 10, number 4 is 13, number 5 is 16, number 6 is 19, number 7 is 22, number 8 is 25, number 9 is 29, number 10 is 32, 11 is 36, 14 is 43, 18 is 57. It's no longer is common, but just for all. Linear mass density, nominal diameter, nominal area. This means you can say one number is 1/8 of an inch, or we call it one division of an inch. There are 8 divisions in an inch, and in Hindi we call it suit is 3 divisions. So we can say 1 division, 1 number, 2 division means 6, then 3 number is 3 division, like that we can move it. For example, 18 is here. Now we go for Canadian sizes. Metric bar designations represents nominal bar diameter in millimeters, rounded to nearest 5 mm. This is Canada size. So the metric is bar size 10, 15, 20, 25, 30, 35, 45, 55. Kilogram per meter, nominal diameter, cross section. European sizes. Metric bar designations represent nominal bar diameter in millimeter. Preferred bar size in Europe are specified to comply with Table 6 of Standard EN 10080, although various national standards still remain in force, namely BS 449 in United Kingdom. In Switzerland, some sizes are different from European standard. So there is then bar size, Australian sizes, then there are, you can say, difficult classes, low ductile, and New Zealand is there. In India, rebars are available in following grades as per IS 1786-2008, FE 415, FE 415D, FE 415S, FE 500, FE 500D, FE 500S, FE 550, FE 550D, FE 600. Rebars are quenched with water at high level pressure so that outer surface is hardened while inner core remains soft. Rebars are ripped so that concrete can have a better grip. Coastal regions use galvanized rebars to prolong their life. BS rebar sizes are 10, 12, 16, 20, 25. Likewise. Jumbo and threaded bar sizes. Jumbo. So we say here jumbo very large format rebar sizes are widely available and produced by specialty manufacturers. Tower and sign industries commonly use jumbo bars as anchor rods for large structures which are fabricated from slightly oversized blanks such that threads can be cut at end to accept standard anchor units nuts. Fully threaded rebar is also produced with very coarse threads which satisfy rebar deformation standards and also for custom nuts and couplers to be used. Note that these customary sizes while in common use do not have consensus standards associated with them and actual properties may vary by manufacturer. There are certain properties of imperial and metric. In this we can see that grades is more important now. Rebar is available in grades and specifications that vary in yield strength, ultimate tensile strength, chemical composition and percentage of elongation. Use of grade by itself only indicates minimum permissible yield strength and it must be used in context of material specification in order to fully describe product requirements for rebar. Material specifications set requirements for grades as well as additional properties such as chemical composition, minimum elongation, physical tolerances, etc. Fabricated rebar must exceed grades minimum yield strength and whatever other material specification requirements when inspected and tested. In US, grade designation is equal to minimum yield strength of bar in KSI. For example, grade 60 rebar has a minimum yield strength of 60 KSI. Rebar is most commonly manufactured in grades 40, 60, 75, with higher strength readily available in grade 80, 100, 120 and 150. Grade 60, 420 MPa is most widely used rebar grade in modern US construction. Historic grades include 30, 33, 35, 36, 50 and 55. Some grades are only manufactured for specific bar sizes. For example, under ASTM A615 grade 40 200 MPa is only furnished for US bar sizes number 3 through number 6, soft metric number 10 through 19. Sometimes limitations on availability material grades for specific bar sizes related to manufacturing process issued, as well as availability of control quality raw material issue. Some materials specifications cover multiple grades and in such cases it is necessary to indicate both material specifications and grades. Rebar grades are customarily noted on engineering documents even when there are no other grades options written within material specification in order to eliminate confusion and avoid powerful potential quality issues such as might occur if material substitution is made. GR is common engineering abbreviation for grade with variation on letter capitalization and use of period. In certain cases, such as earthquake engineering and blast resistant design, when post-yield behavior is expected, it is important to be able to predict and control properties such as maximum yield strength and minimum yield ratio of tensile strength to yield strength. ASTM 706 grade 60 is an example of control property range materials specification which has a minimum yield strength of 60 KSI, 420 MPa, maximum yield strength of 78 KSI, 540 MPa. minimum tensile strength of 80 KSI 550 MPa and not less than 1.25 times actual yield strength, and minimum elongation requirements that vary by bar size. In countries that use metric system, grade designation is typically yield strength and megapascals, MPa, megapascals. For example, grade 400 similar to US grade 60. However, metric grade 200 is actually exact substitution for grade US grade. Common US specifications published by ACI and stated American Concrete Institute ACI 318-14 Building Code Requirements for Structural Concrete and Commentary. ISBN Living. ASTM A2 Specification for plain steel wire for concrete reinforcement. ASTM A184 A184M Specification for fabricated deformed steel bars, mats for concrete reinforcement. ASTM A185 Specification for welded plain steel wire fabric for concrete reinforcement. ASTM A496 Specification for deformed steel wire for concrete reinforcement. ASTM A497 Specification for welded deformed steel wire fabric for concrete reinforcement. ASTM A615 deformed and plain carbon steel bars for concrete reinforcement. ASTM A616M specification for rail steel deformed and plain bars for concrete reinforcement. ASTM A617M specification for axle steel deformed and plain bars for concrete reinforcement. ASTM A706M low alloy steel deformed and plain bars for concrete reinforcement. ASTM 61760M specification for axle steel deformed and plain bars for concrete reinforcement. A706M low alloy steel deformed and plain bars for concrete reinforcement. ASTM A722M standard specification for high strength steel bars for precast concrete. ASTM A767M standard, specification for zinc coated. This is ASTM A76276M specification for zinc coated. So we can say ASTM A767M specification for zinc coated galvanized steel bars for concrete reinforcement. ASTM A775M specification for epoxy coated reinforcing steel bars. ASTM A934 specification for epoxy coated prefabricated steel reinforcing bars. Deformed and plain stainless steel bars for concrete reinforcement. This ASTM 955. Supplementary requirement S1 is used when specifying magnetic permeability testing. ASTM A996 rail steel and axle steel deformed bars for concrete reinforcement. ASTM A1035 standard specification for deformed and plain low carbon chromium steel bars for concrete reinforcement. ASTM marking designations are S billet A615 is S is billet, I rail A616, ASTM A616 A616M, 96A standard specification of rail steel deformed and plain bars for concrete reinforcement, withdrawn 1999, superseded by 96. IR material supplementary requirement, W low alloys like this. Historically, in Europe, rebar is composed of mild steel material with a yield strength of approximately 250 MPa. 36 KSI modern rebar is composed of high yield steel with yield strength more than 500 MPa. Rebar can be supplied with various grades of ductility. More ductile steel is capable of absorbing considerably more energy when deformed, a behavior that resists earthquake forces and is used in design. These high yield strength ductile sheet steels are usually produced using temp core process, temperature, a method of thermomechanical processing that's called temp core, a method of thermomechanical processing. Manufacture of reinforcing steel by re-rolling finished products, sheets or rails, is not allowed. In contrast to structural steel, rebar steel grades are not harmonized. Yet European, another yet across Europe, each country having their own national standards. However, some standardization of specification and testing methods exist under EN 180. Now we have some BS codes here. Steel for BS EN 10080. Steel for reinforcement of concrete, weld able reinforcing steel, General 2005. BS 4449 steel for reinforcement of concrete, weldable reinforcing steel, bar, coil and decoil product. Specification 2005-2009. BS 4482 steel wire for reinforcement of concrete products. Specification 2005. BS 4483 steel fabric for reinforcement of concrete. Specification 2005. BS 6744 stainless steel rebars for reinforcement of and use of concrete requirements and test methods 2001-2009. Then 4881 reinforcing steel part 1 grades properties marketing 2009. Then 4882 reinforcing steel part 2 reinforcing steel bars 2009. 4883 then reinforcing steels part 3 reinforcing steels in coils steel wires 2009. 4844 reinforcing steel part 4 welded fabric 2009. Then you can say tin 4885 reinforcing steel part 5 lattice girders. Here we have seen 1, 2, 3, 4, 5, 6. Lattice girder is 5. 4 was welded fabric. Then 6 is reinforcing steel. Part 6 assessment of conformity 2010. You can say assessment of conformity 4886. BSc and ISO 15630 steel for reinforcement and pre-stressing of concrete testing methods reinforcing bars, wire rod and wire. Steel for this BSc and ISO 15630 steel for reinforcement and pre-stressing of concrete test methods welded fabric. Placing bars, rebars. Placing rebars. It's important. Placing rebar very important. Rebar gauges. Rebar gauges. Rebar gauges are fabricated. Look at rebar gauges. 2-3 pages are left. Let's see how much is that. What is there? Let us see. It's an important one. Let's go back. Let's see. Placing rebars. Rebar cages are fabricated either on or off project site, commonly with help of hydraulic benders and shears. However, for small or custom work, a tool known as hickey or hand rebar bender is sufficient. Rebars are placed by steel fixers, road busters, or concrete reinforcing workers with bar supports and concrete or plastic rebar spaces, separating rebar from concrete formwork to establish concrete covers and ensure that proper embedment is achieved. Rebars in cages are connected by spot welding. Rebars in cages are connected by spot welding, tying steel wire, sometimes using an electric rebar tire, or with mechanical connectors. For tying epoxy coated or galvanized rebars, epoxy coated or galvanized wire is normally used, respectively. Stirrups form outer part of rebar cage. Stirrups are usually rectangular in beams and circular in piers and are placed at regular intervals along a column or beam to secure structural rebar and prevent it from shifting out of position during concrete. Main uses for stirrups is ties is to increase shear capacity of reinforced concrete component. It is included in this welding. American Welding American Welding Society sets out practices for welding rebars in US without special consideration. Only rebar that is ready to weld is W grade low alloy A706. Rebar that's not produced to STM age 706 specification is generally not suitable for welding without calculating carbon equivalent material with a carbon equivalent of less than 0.55 can be welded. ASTM A616 and ASTM A617 now replaced by combined standard A996. Reinforcing bars are re-rolled rail steel and re-rolled rail axle steel with uncontrolled chemistry, phosphorus and carbon content. These materials are not common. Rebar cages are normally tied together with wire, although spot welding of cages has been norm in Europe for many years and is becoming more common in US. High-strength steels for pre-stressed concrete cannot be welded. Reinforcement placement in rolls. Reinforcement placement in rolls. Roll reinforcement system is remarkably fast and cost. Efficient method for placing large quantity of reinforcement over short period of time. Roll reinforcement is usually prepared off-site and easily unrolled on-site. Idea of roll reinforcement was originally introduced by BAM AG and BAMTIC reinforcement technology. Roll reinforcement placement has been applied successfully in slabs, decks, foundations, wind energy mast foundations, walls, ramps, mechanical connections. Also known as mechanical couplers or mechanical splices, mechanical connections are used to connect reinforcing bars together. Mechanical couplers are an effective means to reduce rebar congestion in highly reinforced areas for cast-in-place concrete construction. These couplers are also used in precast concrete construction at joints between members. Structural performance criteria for mechanical connections varies between countries, codes, and industries. As a minimum requirement, codes typically specify that rebar to splice connection meets or exceeds 125% of specified yield strength of rebar. More stringent criteria also requires development of specified ultimate strength of rebar. As an example, AC I318 specifies either type 1 125% Fy or type 2 125% Fy and 100% EFU performance criteria. For concrete structures designed with ductility in mind, it is recommended that mechanical connections are also capable of filling in a ductile manner, typically known in reinforcing industry as achieving bar break. As an example, Caltrans specifies a required mode failure necking of bar. Safety: to prevent injury, protruding ends of steel bar are often bent over or covered with special steel. To prevent injury, protruding ends of steel bars are often bent over or covered with special steel reinforced plastic caps. They may provide protection from scratches and other minor injuries, but provide little to no protection from impalement. Designations: reinforcement is usually tabulated in the reinforcement schedule on construction drawings. This eliminates ambiguity in notations used around world. Following list provides examples of notations used in architectural, engineering and construction industry. This is New Zealand. Explanation is HD16 like that. We'll take it later on. Reuse and recycling. In many countries, after a demolition of concrete structures, workers are called to remove rebar. They scour site, extracting metal using bolt cutters, welding equipment, sledgehammers and other tools. Metal is partly straightened, bundled and sold. Rebar, like almost all metal products, can be recycled as scrap. It's usually combined with other steel products, melted down and reformed. These are references. So this is over. We had to just say that. I just tell that this is designations. New Zealand said something. New Zealand says high strength 500 MPa 16 diameter rebar specification center strength in both top and bottom face in each way as well as longitudinal transfers. This is HD 16-300. This is, you can say, specifying high strength HD as 500 MPa 16 dia 300 centers distance on both top and bottom. EW is here. That's what easy way. Easy each way as well. 3D12 3 mild steel 300 MPa D12 die rebars R8 D grade 300 MPa smooth bar struts spaced at 225 mm maximum center by default. In New Zealand practice, all strips are normally interpreted as being full closed loop. This is a detailing requirement for concrete ducted in seismic zones. If a single stand of strap with the hook at each end was required, this is typically be both specified in the United States. Number 4 at 12 OC TBEW. Number 4 rebars spaced 12 inches on center distance on both top and bottom faces and in each way as well. Longitudinal transfers. Number 3 bracket 3 number 4 rebars usually used when rebar perpendicular to each other. Number 3 ties at 9 OC. Number 3 rebars used as straps spaced at 9 inches on center. Each set consists of 2 ties, which is usually illustrated. And number 7 rebars spaced 12 inches apart, placed in each direction, each way and on each face. So we have completed this file of Wikipedia, and also it's time to go and take care later on. So I think we have done good, and I take my opportunity